Welcome. In this video, we will explore some strategy for literature search. So you remember in the previous video, I showed you some sources that I were citing, and in this video, you will learn how were I able to identify the sources. Okay, so that's basically you will learn the strategies for like so by the strategy for finding the relevant sources that you can learn about from which you can learn about your research and you can cite in your proposal and in your paper. So in this by the end of this video you should be able to apply advanced strategy for literature search, and you should be able to critically evaluate sources for credibility, relevance, and impact. So you will learn this, like how could you evaluate the source for its credibility and for its impact and the relevance. This is something that is more or less topic dependent, so that you'll be able to judge this based on what you are doing. Yeah. Whether this is relevant for, let me get this here. Uh, Whether this is relevant for the task that you are doing or not. But there are strategies for knowing whether this is credible, and there are strategies that you will learn where you learn about the impact of the source that you are citing. Okay, so let's get started. So in order to find these sources will you will not get them by regular Google search. You need to go for academic databases. So there are academic databases where you go there and then you will find this academic literature or peer-reviewed literature. What is peer-reviewed? So in for academic research, uh, in order to to like what you generally do is that like you conduct your research. After you conduct your research, you will write like a manuscript. You will submit this manuscript for a journal, like a peer-reviewed journal. And this peer-reviewed journal, it has a reviewer. So these would be your people who are working in this field who can judge the quality and the merit, the scientific merits of your work, and provide feedback. So there they could review your work and then they will make like provide the editor, the journal editor, with a recommendation so that the editor can make a decision. That decision could be to you need to like revise your work, like make a major revision for your work before it gets accepted for publication, or a moderate or a minor revision, or it could be like reject, like they could reject your work and tell you this work require so much work to be accepted, so you might revise it and resubmit, or they might just reject it completely and tell you this work is either not suitable for our journal or not suitable for publication. Like, yeah, it's not at a good quality and it's not suitable for our journal. Yeah, or out of the scope of our journal or something like that. Yeah, so that's called like the peer review process. And generally, for academic research, we support our. Remember, I told you everything you write, you need to provide evidence, and so we provide evidence and we support our arguments with these with mainly with this peer review publication. Other types of sources we use, which we can also use, is called like gray literature. So you have like the peer reviewed publication, but you also have something called like gray literature. Gray literature, these refer to uh, like research and information that is produced outside the traditional academic publishing channels that I just described. So it is often not peer reviewed. So you don't get like this peer review. Example would include like government reports, for example, USGS reports. They are very high quality. That doesn't mean that they are less quality than the academic literature. They are at a very high and good quality, but it's a different type of literature. So we call this like gray literature. So government report, the policy papers like thesis, like if you are doing a thesis or a dissertation, so you can do a thesis or a dissertation, uh, and you didn't publish it, that wouldn't be count as good as a peer review publication, because the thesis and the dissertation without publishing it was just reviewed by your committee, but that doesn't mean as if it is reviewed by external reviewer who are expert in this field. Because your committee member might not necessarily be expert in this field as other uh, researcher out there who have very extensive and wide experience in that field. Yeah. Conference proceedings. So these are example of gray literature. So gray literature may not be peer review, but it is like even though it's not peer review, it can still be authoritative and credible, but depending on the source. Yeah, but as I will show you now, for peer-reviewed literature, there is a system, like there is a citation system and there is a metric system where you can evaluate the credibility and the impact of these sources, as I will show you now. Yeah. And there are other non-peer reviewed sources that it's not common to use them in research paper, but in research papers or proposals, but you can still use them. So that could include like a news article, for example, or an opinion piece, or a blog post, or so these are non-peer reviewed, and you don't like that wouldn't be like you can use it if you want to. It's not common to use them, but if needed, you can use them. Of course, if that's something you need, then you can use. There's nothing wrong with using them. Yeah. Other like gray literature would include so like non-peer reviewed and gray literature would include, for example, book chapters. So like if you want to cite a book or a book chapter, you can also do this. But remember, these are not peer reviewed. Like the peer reviewed, these would be the most rigorous, and we will. Okay, so where can we find this like peer-reviewed papers and this gray scientific like research literature, basically research literature? Like where can we find this? Like whether peer-reviewed paper or gray research literature. So you need to go to academic databases. So what are the common academic databases? So the most common one is like Web of Science, and now there is a Scopus, and then there is Google Scholar. And there is a difference between these two. Like, so there is a difference between the coverage and also quality. So in the Web of Science, this provides like extensive peer-reviewed journal coverage with powerful citation and analysis tools. So both Web of Science and Scopus, that's what they provide, like extensive journal coverage with powerful citation tool, and that is what we do for in-depth academic research. And Web of Science and Scopus, they might include like some gray literature, because so Web of Science, as I will show you, it has a score collection. So score collections, that would be like journals that they evaluate them and rank them according to their quality, and that would be like their core collection. So there are like research or academic journals. There are like the standard research and academic journal, but now recently has been a trend where you find these predatory journals. So predatory journals, these are journals that are out there that are just for profit. So they don't really have a rigorous peer review process. So basically you just submit your paper, and then after 2 weeks they will tell you, oh, your paper got accepted, pay us like $2,000 or something. Yeah, this is not uh, these are predatory journals. So that's why we, like in this Web of Science and Scopus, all these predatory journals, they will not gonna be listed. They will not gonna be indexed by like Web of Science or Scopus. These types of predatory journals, they will not gonna be indexed because they will assess all the journal, and they will only include like serious journal. Like these non-serious journal will not, not be there. That doesn't mean that everything there might. Some journals now are kind of like sneaky, yeah, and they might still be indexed there, but they might not be that high quality. So it will not be terrible, but it might not be that credible also, yeah. And so that would require extra experience as scrutiny from like your side, yeah. So here, like the Web of Science, extensive coverage of peer-reviewed journal with limited gray literature. Now, Web of Science now has is a core collection, and it has a wider collection which will include, for example, some conference proceeding and things like that. Okay. For the Google Scholar, the Google Scholar, it has a broad coverage. So Google Scholar usually has a broad coverage. So it include like peer-reviewed, but it also include non-peer-reviewed and gray literature. So non-peer-reviewed, it could include, as I mentioned, like book chapters. It could include government reports. It could include preprints. Preprints, these are papers that are not published yet. So sometimes, like you have a paper, you want to get it out, people to read it before it get published. So that's called like a preprint. So it will include like preprints and like this like non-peer reviewed and gray literature. But generally, we start like, or at least that's how I do it. I generally start, and I will show you this. I will generally start with the Web of Science core collection, and then after this, I will augment my search with Google Scholar just to make sure that I didn't miss like an important government report, like UN report or USGS report, or an important source that should be included that I didn't include. Yeah. So usually, but I start by this one and I augment my search or improve my search with Google Scholar. So that with respect to coverage and source quality. Source evaluation, generally high quality, reliable sources. I told you generally because some journals will, because remember, like these, some journals will still not be very rigorous in peer review, but they are still have high impact because their article gets cited a lot. So you will still find them. In Web of Science and Scopus, some of these journals. The impact of the article, it depends on, or the impact of the journal, it depends on the number of citations that the article of the journal gets. So there's something called like impact factor, and in this impact factor, they basically measure it how many articles has been published, and like they divide the number of citation by the number of article for like I think the last 2 years. It gets updated every 2 or 3 years, and then it gets updated every year, but they like the time span is like the article published in the last 2 or 3 years. They see the number of articles that were published, like they get the number of citation divided by the number of article, and that will give you the impact factor of a journal. So in my field, for example, different journal will have different impact factor. Like a journal generally with an impact factor of 4 or above, that would be like a good journal in my field. In other field, it could be different. Like in my field of groundwater hydrology or water resources in general, water resources engineering in general, like a journal with an impact factor of 4 or 5, that would be like a good journal. Yeah. Other field, like in biology, that might be an average journal because it's a smaller field. Yeah. Again, 4 journal means that like the average article will get 4 citations per year or something like that. Something like that. I don't remember the exact definition, but it's not important. But the exact definition I think is not important, but you just know that the impact factor of journal and we will look at this detail. Okay. So source evaluations has generally high quality, reliable source, but here this requires careful evaluation for quality and relevance. Yeah. So you need here to, because some of these might not be peer reviewed, but this also sometimes here some journals might, as I mentioned, their quality might not be that good. So don't also like you need to do some evaluation here, especially for some type of journal. Okay, so the tool, like the advantage of using this one, it has an advanced citation analysis tool and advanced search tool also. This is basic search and citation tool. So I will like make a demonstration now and show you like these advanced citation and analysis tool and why we use something like the Web of Science, and it's very useful. So this ideal use in-depth academic research. So for your proposal, this semester, that's like you will use like Web of Science or Scopus, whichever you prefer. I think FGCU have access to both of them. This is for quick and broad searches and to augment your search. And as I will show you, yeah. So the usability of this one requires subscription and specialized training. This one is accessible and user-friendly and free. Yeah. But this requires some training, which we will do now. Okay. Okay, so let's just get started. Start with like the Web of Science and learn how to do some literature search strategy, like learn how to do this usability, like how to use something like the Web of Science. Again, I will just do the Web of Science, but like if you want to use a Scopus, it would be more or less the same. Yeah. So, but I mean, it would be more or less the same. So let's just get started. So literature search. So basically, like if you obviously like just as you will do a Google search, you have a certain topic in mind, and for this topic you need to identify like the right keywords, because without the right keywords you're not gonna get to the right sources that you're looking for. So search engine automatically looks for different form of the search term. So like for example, like if you are using a word like behavior, uh, its English spelling would be different than its American spelling would be different than the British spelling. That any search engine will automatically look for both version of this. But for example, if you're searching for the word groundwater, sometimes it's written as one word. That's the right way of writing it. That's the correct way of writing it. So groundwater is just one word. But some people will, especially old sources, they might write it as two words, ground as one and water as another word. Or some sources will even write it with a hyphen. So that you need to account for, because that the search engine might not automatically look for these things. Okay, so here, now let's look at this example. So here in this example, what we want to do, we want to multi-model uncertainty. That's the paper that I'm writing, or this is the topic that I want to search for. Multi-model uncertainty analysis. So it's a lot of things happening here. So one is uncertainty analysis. Another is multi-model. Third thing, like simulation optimization, and then in groundwater. So you see like a lot of things is happening here. So simulation optimization, that's a technique. So that's like one thing. Uh, Uncertainty analysis, that's one thing. That's what we are doing. Multi-model, that's specific technique in uncertainty analysis, and we don't want for everything, like we don't want this for psychology, for example, or material engineering. We want this for groundwater hydrology, yeah, water resources engineering or groundwater hydrology. So there are four things that are happening here. So how could I get this search? How could I you need to identify like what is the main things that you're doing here. So the main things that you're doing here is that obviously you're interested in this topic of groundwater. Yeah, that's the main things that you're doing here. So it's obvious, like when you look at this, like the main thing, what am I doing here? What's the main thing? So I'm working on groundwater. That's the main thing. And I want to do uncertainty analysis. Okay. And I want to not any, there are so many methods of uncertainty analysis. I want a specific method of uncertainty analysis, which is multimodal. Yeah. And then in groundwater, I'm using a technique like management technique, which is simulation optimization. That's the management technique that I'm using for groundwater simulation optimization. What is, okay, so let me explain this to you so maybe you'll be able to follow. What is simulation optimization? Simulation optimization is that like you have a model, yeah, and on the top of this model, you put an optimization algorithm to optimize your strategy, to optimize your design, for example. So let's say I have some contaminant plume here. Yeah. So I will make a model that will simulate the flow of this contaminant plume. Okay. Optimization method is that I put like an optimization algorithm on the top of this model to find the optimal solution. So like let's say I want to design a pump and treat system, like put some pumping well here so that I will capture this plume. Yeah. I'll capture this plume. So that would be the optimization algorithm. So the optimization algorithm will try to put like tell you, okay, where can you locate this pumping well and what pumping rate do you need in order to capture this plume. So simulation would be the simulation models that would be like mod flow, for example, and the optimizations that could be whatever optimization algorithm you want to use for optimizing your design. Yeah. But what is multimodal? Like the problem is that this model, like this MudFlow model, or this is just one conceptual model of the subsurface, but the subsurface is unknown. So we could conceptualize the subsurface in different ways. So you don't want to base your design on just one model. So the way to account for this uncertainty in your design is that you develop like several conceptual model for your subsurface. Like instead of just having one conceptual model, you have like several conceptual model for your subsurface, and then you run your design or you find the optimal solution. You find an, so like let's say here's one model, here's another model, here's the third model. You find an optimal solution that will satisfy this different conceptual design. So then now your design is not just based on one conceptualization of the subsurface, but multiple conceptualization of the subsurface. Yeah. That is basically the idea of like multi-model is that you base your design on multiple model rather than one model. Okay, so what keyword should I look for? Obviously, the most important keywords that I look for would be groundwater and with different writing. So that would be the most obvious thing. So identifying identification stage for a systematic review. So this was done in 2024 and we will do it now in 2025 and see the difference. So here, remember, like a groundwater, you can write it like this, groundwater, or you can write it like some people will also write it like this. So here, that's basically how so if I search it for groundwater, I found like more than 130,000 records. So I will go in this 130,000 records? Of course not. I mean, you cannot, go through all these records to find what you want. So you need to refine your search. So how could I refine my search? So to refine my search, I need to, what am I doing? I'm doing simulation optimization. So I'm doing some optimization. So I need to refine my search because I'm not interested in all these sources about groundwater. I'm only interested in sources about groundwater that uses something like optimization. So what term should I use here? Should I use simulation optimization? If I use simulation optimization, that is kind of a very specific term, and not every article, when I search for it, will use this term. So when I conduct this search, what Web of Science will look for, it will look for the keywords of the article, it would look the title of the article of the source, and it would look at the abstract of the source. That's what it should search for. It does not read the whole article. It just looks in the keywords, title, and abstract. Yeah. and other information like author affiliation and so on and so forth. So if I look, this is because some papers might not use this term, a specific term, simulation optimization, but they might use something like we optimize the solution or we find the optimal solution. Again, they are doing simulation optimization, but they are not using this term. So here you need to be very careful, because if I use simulation optimization, I might not get all the sources that I'm looking for. So what is the essence of this? The essence of this is that like optimization. I'm just looking for optimization. So basically, I would refine my topic by using the word like optimization or remediation. Because why did I use the remediation? Because remediation in groundwater, they often use the word optimization. They use often optimization technique. So I used here, so to represent simulation. How did I know this? How did I know that remediation generally use an optimization technique? I know this by experience. If you don't have this experience, that's fine. If you just included the word optimal, that would be good enough. And you see here, I'm not using even the word optimization. I'm using it with this like special simple. And you use it with this special simple because this special simple would mean all the, it will include any, as many character with like many character after m with all their combinations. So that could be like not any character after m. This is optimum. So that could be optimal, optimal, optimization, optimizing, whatever. Yeah. So that would include any character with all the combination. So now this reduced my record to from 100 something to 15,000 something. Okay, now much better. But now how could I get like this multi-model? Now again, see this multi-model, that's a little bit tricky because multi-model, again, not all the author might use this term. So that here could be like, that would require a lot of like creativity and care and to be careful. So see here, this could be all the words that could be used. Like it could be multi-model like this as one word, or it could be, so here, so I'm telling him groundwater, this version or this version, and optimum or remediation. Yeah. And then, and like refines this by like, I need like this to include like multi-model or multi-model with dash or multiple model or model selection, because sometimes people will not use multimodal, but they will use model selection. Model selection means what? Means I have many models and I'm selecting one of them. Model averaging. Model averaging means what? Means I have multiple model and I'm averaging. Model combination. Again, I'm having multiple model and I'm combining them. Model stacking means what? I have multiple model and I'm stacking them. So you see here, I'm using all these combination in order to find like all the sources that are that would include like that they will have groundwater, it will have optimization, and it will have model stacking, model structure. What does model structure mean? Model structure means that you, like as I explained to you, like you have different model structure. Like you don't have just one, like you have a model structure. Like let's say the subsurface looks like this, or it looks like this, or it looks like this. So when you start talking about model structures, this means that you will have different model structure. Conceptual models, like different conceptual model, conceptual uncertainty. Because if you have a conceptual uncertainty, you generally account for this conceptual uncertainty by multiple model. I mean, how else could you account for conceptual uncertainty? Because conceptual uncertainty is just like you use like a conceptual model. Model error. If your model has like an error, one way to account for this error is that like you account for multiple models. What could be like a second model? Some people will say that like we use the second model or a second conceptual model or two model or three model or two geostatistical. So that could be also another, like they use two geostatistical conceptualization or two geostatistical model, three geostatistical, multiple geostatistical, two recharge, three recharge. So again, that would be two recharge model, three recharge model. So you see, I put all again. This is too much. I know this is like you don't need to do this. I don't expect you to do this, but I'm here. I just want to show you like how you how sometimes you need to be very accurate in order to get like exactly get so that you can find as many records as you can that are relevant for what you are doing. So let's see how to do this. So that's just an example, but let's see how to do it. So let me open here how to find like the Web of Science. So to find the Web of Science, you basically go to FGCU library. That's how you go there. And at the FGCU library, go to databases. And then at the databases, you go to W. And at W, you find see here, Web of Science, all databases, search all Web of Science databases simultaneously and select individual databases or Web of Science core collection. So this thousands of peer-reviewed, high-quality scholarly journal published worldwide in science. So these are like the core collection. These are the high-quality peer-reviewed like scholarly journals. So we generally do this one. Okay. So you go here. If you are on campus, you will be able to access it on campus. If you are not on campus, you still like you need a VPN. So check online how to get a VPN to access Canvas resources from off campus. If you need help, contact the help desk. You'll find their email or phone number. Just call them, and then it's easy. Like just find the FGCU VPN, and then you'll be able to access all these campus resources from anywhere on campus, whether you are anywhere. Yeah. But anyway, so here you go to the here, and then you start your search document. So here, we will write like groundwater. Let's just write groundwater, yeah, and let's do search, yeah. So if we uh, so you see here groundwater. Remember here we had in 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 2024 we had like 13,134. See now much we have much more, yeah. So like this is groundwater, yeah. But let's just do groundwater. Let's do or groundwater. Yeah, so like let's see if we're gonna get more sources or not if we wrote it in this way. Or yeah, you put it here between parentheses because you want to find the exact word. Like if you want to find the exact words, then put it between parentheses. So let's see if we did this, are we gonna get more sources or not? So if we did this, yeah, we got a little bit like 4,000 sources more. Like remember, let me just show you how to go back. I think you just okay, just go. Okay, smarter. Yeah, let's just do this one, groundwater. So groundwater, oops, was once out like only uh, one 2,100. But if you put, see now, if I put like all this different combination like ground, that's another combination, or ground water, then I got like more sources. Yeah, I got like 2005. Okay. Uh, okay, so that is like you got more search here. Okay, so now let's do this change. I don't know, they changes this interface is not like what I'm used to. I'm not like I don't usually prepare for this lesson because that's exactly what I want to do. I want to just like do this live with you and have like this metacognitive reflection because see now they changes the interface. That's not the interface. Okay, here, this is the interface that I'm used to. Okay, like so they have smart search and they have advanced search. So that's the interface that I'm used to. So in this interface here, you see here all fields. This search. Let me make it a little bit bigger so you can read what I'm doing here. So like this is the interface that I'm used to. And Web of Science core collection, like you can select like the core collection or all these other databases. So here, like we just select the core collection edition. So this is edition Web of Science expanded present. So that's basically their core collection. You can select some of these databases. We generally select all of them. Here, all fields, all field search, all searchable field. So basically, all searchable fields that would include the titles, that would include the abstracts, that would include like the keyword, that would include the author information, or you can just search topic or title, or we usually do all field. Yeah. And then, so let's do like groundwater. So here we have like groundwater, groundwater, and groundwater. Then add row. What row do you want to add? Like we want to add the optimization, remember? So, so we want to add like optimization. And so let's say optimization. Yeah, I still have this here, optimization or remediation. So if I search this, then I got like about 30,000 of them. Yeah. Now I want to add row like so here when you add row it tells you like what do you want like and or not. You can also use not. Yeah. But now I want to add row, so I want to add row, and what do I want to add in this row? I want to add uh, I want to add all uh, this keyword. Remember, like this parentheses means like if you have this parentheses means that it's like programming, yeah, like means like this one or this one, like that's the meaning of this quote mark means like find the exact word, like as it is exactly written. That's like this quote here means like as it's exactly written. This parentheses means that it will search this one or this one or this one, yeah. But in that case, like since you're using or, it really doesn't matter. But here, like, see, I'm putting like this multi-model, like all these keywords that we discussed before. So now let's do this search. If we did this search, now it is like a much bigger than what we have here. So remember, like when we did here, we had like 138 records. Now we are getting more records. The reason we are getting more records is either because we are they included more in their collections. So like let's say here, that would be like in this collection they included the like science citation index expanded, for example, like they included conference proceedings, they included book citations. So if you remove like book citation, this one, and you just selected the core collection, that might still like you still have a lot of them. Yeah, 300. So that's the number of documents. Let's refine it even more. See, let's see here. So science citation index expanded, social science index, art and humanity. Oh, see, conference proceeding. We don't want conference proceeding. Emerging source citation index, current chemical, I don't know what these are. But yeah, let's remove the conference proceedings. Uh, and again, it's still like you're getting a lot of sources, yeah? Oh, see, my the first article, most relevant article that Web of Science suggested was actually one of my articles. So here, evaluating two multi-model simulation optimization approach for managing groundwater contaminant plume. Yeah, it's the Journal of Hydrology. You see here now. Uh, but anyway, you got like 340 citations. This was the most relevant one. That's good. Like 340, that's not like a big number to review because you can what you can do like it's only 8 pages, and what you can do like what we generally do, yeah, you can you can even like the size you select the size. I usually put like 50 pages. So it's only 8 pages. So basically, what you do, you just like read the title here. I will show you this later. But before we do this, let's just check what this information it has here. So this paper, basically, it will tell you the paper. It will tell you how many times this paper was cited. So this paper was cited like 10 times. If you clicked here, it will show you like who cited this paper. So for example, like the most recent citation. And again, this is not like it might be cited more than that. Like you see, it does not have any citation because that does not like one drawback about the Web of Science. It does not get updated quite frequently. I don't know what is their update, like how often they update it, but uh, I think every like month or something, but or it could be that yeah. But here you see this is like these are the papers that cited this work. So you see like this paper cited this work, this paper cited this work, and this paper cited this work. Okay. Then you go back here. This is the reference. This is how many paper were cited in this work. So if you want to see, so this basically these are the papers that I cited. Yeah. So I cited one of my papers here. I cited another paper of mine here when I wrote this, and oh, I cited one more paper of mine. Yeah, usually you shouldn't do this, like you shouldn't cite your paper unless it is relevant. One more here. But sometimes you cite your paper because that will be the continuation of your research. And these are the papers that I cited. So in this paper, I use like 114 references. In your research proposal and your research reports, how many paper references are we expecting you to cite? I don't remember the exact number, but check the rubric. It's around like 12 or 15 or something from 10 to 15. I don't remember. You can just check the rubric. Yeah. But anyway, that is that is basically here you can do a quick filter. So if you find like the highly cited paper, like if you click this and you did refine, that will tell you the two most highly cited paper about this topic. So one of them would be like a review article, review source of hydrological model uncertainty and advances and their analysis. So that's like a review article. And then another one is global analysis of blah, blah, blah. Okay, so that's two highly cited paper in this topic. Uh, uh, Review article, like if you just want to look for the review article, that would be this review article. Review article that will not be like a research article, but a review article. It summarizes the current state of the science of this field. Yeah. Open access article. So here, if you just want to refine, like let's say I just want the article that was published in the last 5 years, you can select this one, and that will reduce your article to 133. If you just want to, oops, to find like the new article. Now here you can refine. Here the authors like what are the authors that who publish in this field. So Frank Tsai, actually that was my PhD advisor. So he published like 12 papers about like this topic of simulation, optimization, and multimodal. See, that's Wolfgang Novak. He's also a colleague of mine. Thomas, he's also a colleague of mine. So these people. You see, like it's a small community. So I don't know these two, but like it's a small community. So we all know each other. Yeah, and we all work it with one another. So here, publication title. That is if you just want to find article in certain journal. So let's say like for example, I know like the good journal in my field would be the hydrogeology journal, water resources research. These are the top two journal in my field. Yeah, like in the field of groundwater hydrology, the Journal of Hydrology and Water Resources Research. You get to know this by through experience. And then hydrology journal, that's also a good journal. Science for the Total Environment, that's a good journal. Um, Groundwater monitoring and remediation. I'm not familiar with this journal. Groundwater journal, that's also an That's more like a practical applications and more like industry. Remember, I told you in re-engineering there is more like R&D research and more like practical research. So you'll find it here. So that's a good, also a good journal you can include. Hydrogeological processes, hydrogeology and earth system science. That's so the best three journal in my field would be the Journal of Hydrology, Water Resources Research, and this one, Hydrogeology and Earth System Science. And Advances in Water Resources, another good journal. So these are the top journal, like these two and like these two. But you can like if you want to refine them by like these uh, agricultural water management. That's again another good journal. Uh, okay, yeah. Environmental modeling and software, that's also a good journal. So if I want to refine it by like the good journal, I can just and that end up with 135. So these are like a good journal, yeah. And then so that is uh, that's like you can refine it by journal. If you just want to see like what Frank Tsai published about this, so that's his recent. Here, see, they are sorted by relevance. Let's You can also sort by not by relevance, but by date. Yeah, news first. So here I'm sorting it by date. So like the last thing that Frank Tsai published about this was in about this topic was in 20 Journal of Hydrology, and this was his publications. That's how many it was cited. So that's the news first. Sometimes you want to by the citations, the high citation, like which his top cited article. So his top cited papers, for Frank Science, this topic was in 2013. That was the article, and it was cited 132 times. Now let's get back to our search, our original search. So to get back to your original search, I think you go here. So that was like everything. I could sort it by also the high cited first. So that would be the high cited paper in this topic. It was published in Science and Total Environment, GIS-based groundwater potential analysis using novel ensemble weight evidence for logistic regressions. That's probably, I can tell you, irrelevant paper. Yeah. So remember we talk about relevance. So this now that's a good example. Remember I told you about credibility, impact, and relevance. So with respect to credibility, this is a very credible source because Science of a Total Environment, this is a credible journal. And like you see the journal impact, remember I told you about the impact factor? See, it has a very high impact. So the impact factor is 8. That's a very high impact. See, the category of the journal is Q1, so it is ranked like from the top journal. So category rank environmental science, so it is ranked in environmental science and it's ranked as number 39. So in environmental science, this is its rank is 39 out of 300. And so in environmental science, Web of Science has 374 journal, and this ranks that much. Yeah. Journal citation indicators. That's like you can also learn about this. This is journal citation indicator from Journal Citation Report measures the average category normalized citation citable item. So that's basically tells you like within this field how this journal is standing. And again, this is still a high number. Yeah. Like journal citation indicator of 1.5, that's still high. The citation factor is like the average article will be cited like 8 times each year or each 2 year. I don't remember. But anyway, but this is like Q1 journal. This means it's a top ranking journal. So remember, like let's talk about like the three criteria that we have. Credibility, yes, that's a very credible journal. Why? High impact factor, high citation indicator. But the impact factor is generally also not, because some journals they might have a high impact factor, but they are not that credible. So credibility is also based on the reputation of the journal. So impact factors, that's one indicator, but that's not the only indicator. The most important indicator is the reputation of the journal. And as a researcher you will know that this journal has a rigorous peer review or this other journal does not has a rigorous peer review. So, but we know here this journal Science of the Total Environment that has a rigorous peer review. So that is credible. With respect to impact, is impactful because it has high citation. But with respect to relevance, that's a different issue because relevant could be it depends on the topic. So with respect to the topics that I'm interested in, which is like the design, simulation, optimization, and designing this remediation system, that is not relevant for me. Yeah. Uh, Here, this is another example. Hydrology and Earth System Science. That's an EGU journal. This one of the top journal. It will not have an impact factor as high as this one, but it's still a very good journal. See, its impact factor is 5.8. Uh, See, its rank in geoscience. Its rank in geoscience is number 22 out of 58. Its rank in water resources 12 out of 131. Its category is 1. Its citation indicator is 1.4, similar to the other one. Why? You would expect it to be lower, but actually it is not, like, because it has a lower impact factor, but because remember, water resources is a smaller field than environmental science, so that would be like a high impact. And it's like a Q1 journal. So here, these are two examples like of highly impactful. They have like a high citation score, high quality. They both come from good quality journal, but they both are irrelevant to the topic. So, like you see here, remote sensing and environment. I'm not familiar with the journal. Hydrogeology journal. That is a good journal. This article might be relevant, but it's old. Like if you want to cite it, that's up to you. Yeah. Okay. So basically, that is how. You can also cite, like, look by the affiliation. Like if you looking maybe somebody in Florida, so you can see like Florida. Did anyone in Florida publish this? Uh, so in Florida, yes, we have Florida State University. So that would be somebody I know also, and Florida State Department of like if you look this, like let's look this Florida State University, that would be like Minge. That would be somebody that I know. So they have like three results. Yeah, see Minge here. The other one like Minge, and that would be like, oh, that's, yeah, that's me and Minge. Something I publish with Minge. So that would be also my article. So that would be like in Florida. Like, so who in Florida is doing these things? So that would be like, you can also know who's in Florida is doing these things. But anyway, that's basically like how you do this search. Yeah, I hope this video is not getting very long. But anyway, now there are other search operators that you can use, like near, same, not, and, or. I'm not gonna go into this in details, but you can play with this on your own. So parentheses for combining search. So basically parentheses, I'm telling him like use this parentheses groundwater or groundwater and sustainability. So that will find everything about groundwater and it will filter it by sustainability. Truncation simple, so basically zero or more characters. So here geo and physics, so that will include like anything like hydrogeophysics will be included, hydrogeophysical, hydrogeophysics, bio hydrogeophysics. So anything here, any number and any number here. Zero, this would be only one character. So here, if you just like if you use this dollar signs, would be zero or one character. So this means that this will give you, like if you're looking for different types of PFAS, for example, so that will give you either zero or or just one character. So that will give you like BH, like with like will give you only this one PFHX or PFHA or S or just like this one, but it will not give you with two character. Like this will give you any number of characters. This would be only one character. This is one character only and can be replaced. So here, this is just one character and can be repeated. What does this mean? So this means that uh, I, it will only search here for one character. So that would be like an X or an E or a B or something like this. Proximity operator. So like if you use this quote, that will give you the exact word. Like here, it will give you climate change, but you can use like near, like the default is 15 words. So like you can say like climate and something like Could be like 5 words here, like near, like so they could be and policy. So there would be 5 words between climate and policy. And that sometimes, remember, it could be like multiple conceptual model. So I could just write multiple and then model and near five. So that will give me anything between, like up to 5 words. Same, this is in the address. So if I want to find like in the address, that would be like Naples, same, Florida or Florida, because Naples, it could be in Italy also. To search for Naples, Florida, and not Naples, Italy. So in the in the same uh, in the same like here, let's go to the search. In the search, you can add a row, and then you can add like actually you can add here like you can say like, let's see how to do this. You can say like, I think this, I don't know how to write Tallahassee. Tallahassee, same, and then you write same, Florida. So Tallahassee in Florida. I mean, probably I misspelled Tallahassee. Oh, I didn't. I don't know why I couldn't find an old field. Oh, because that's in the address. Yeah. But yeah, you can just like in the address, you can just write Tallahassee. Yeah. Or you can write Florida, Florida, or FL. Yeah. So you find like 9 results that are related to Florida. Yeah. Yeah, this is again one of my articles. But you can, yeah, you can find people in Florida who are doing this. Okay. Uh, but okay. Then you can apply filters to your search record. We've seen this, like you can filter by date, you can filter by publication type, by journal, subject area, control vocabulary. You can expand your search. You can citation analysis and key article or shared reference and related articles. So we looked at this one. So let's look here. That's also very important search strategy, and I want you to learn this search strategy. Let's go back here. Let's just remove this one. So let's see. I here like we don't we cited by the relevance. Let's just go back. So let's say I found this article and this article exactly matches what I'm doing. This is exactly what I want. So, and I want to find more like this article. How can I do this? If you clicked here, citation, and look for the articles that are citing this article, that would be something similar that you want to look at. So if you find an article that you said, yes, this is the article that exactly I want to follow, or this exactly what I'm doing, then you might want to check like the articles that are citing this article, because this would be newer article and this would be also related to what you're doing. So that is here uh, uh, like shared references in related articles. Yeah. And in that article, when you read this article, you will also find a lot of articles that or papers that are related to what you are doing, like the original one. Like so here, like from these guys, like when you read it, then you say, oh, that's similar to what I'm doing. Oh, this is similar to what I'm doing. So if you look here, you will say, okay, this is similar to what I'm doing. So like look here, for example, like you open the article. I'm not sure if this is open source or not, but we have like FGCU is very good. We have subscription in many of these journals. So, and if you don't find like a journal article, like ask the libraries, they will get it for you. But generally speaking, we have. So I'm here trying to get the full text of this article available online. Where can I find it? Yeah. So yeah, so you go here. See, this is the article. It's available. Like you can read it here. You can read the PDF of it. And So like you read this article, see this is the article, and once you start reading here, you say, oh, this is relevant to me. This is relevant to me. This is relevant to me. Okay. So you can do citation analysis also. That's like another thing that you can do here. I mean, if that's useful to you, I think citation analysis. Where do you do this here? I mean, I don't generally citation topic affiliation. How to do citation analysis? Citation analysis basically will tell you, will provide you like a report about this. But what we generally do, like if you want to review this one, like you read the title and you start like reading here. This is the abstract. If it's relevant to you, you can just like come here and add to your mark list. Yeah. I will show you like next time like how to uh, uh, like for how like we'll go in details how to find like, but like let's say this is something relevant to you. What I generally do, I will put it to my market list and then I will come here, and that would be like one article. Like next time I will show you like how to use the Zotero to export like this article. Yeah, and save it to your list. But like one thing you can quickly do here, you can just like add to my market list, and then let's put like few of them. Like so you can say this, add this to my market list, add this to my market list. So you can say add to my market list, and then you can at the end you can export endpoint. Like you can just export as a plain text. Uh, no, you go to where is your market list. You want to export your market list only, not everything. So here, if you want to export like all the citation, but like let's go like yeah, this is analyze result. So if you want to analyze the results, this will tell you like uh, all these records are from water resources and environmental science, engineering, environment, and like you will see water resources. That was the ones that has the topic most. So you can do the citation report also if you want to do this. But the citation report, uh, that's like if you want to analyze this. But I just want to see like how can. So I have this is my market list. Uh, uh, view your search history. Maybe. Oh, here I think that's my market list. So you see here, this is my market list. It has this four things that I added, and then I can export it. Like you can tell him export, like I will just export it as a plain text, and then it tells you here these are the four records. Like what do you want to export? Like do you want to export the author title, or do you want to export the abstract also? I will export the abstract also, and then once you have it here, then you see here this is this four records that you have. Okay. But next time I will show you like how you can get like the full text of these articles and start like organizing them and reading them. But for now, let's just continue with this. Uh, you can, yeah, so citation analysis of key article, author affiliation search, we looked at this. Citation tracking to improve your results, citation analysis. So we looked at this like highly relevant paper. Like if you find a highly relevant paper, how you can use it to describe, like how you can use this highly relevant paper to find more article related to what you do. Shared reference, we looked at the shared reference. Author affiliation search, we looked at this. Key researcher and institution in your area. We looked at this, like what are the key institution and researchers uh, that are doing. So like here, we looked, this is a key researcher, but key institution also you can find it here. So let's say like you're looking for a PhD opportunity, for example. So in this topic, so you can find like what are the top universities that are doing this. You can find like key This is country or region, but affiliation, yes, and department. So you see here, these are the top universities that will be doing this, like Louisiana State University, this university, this University of California, Riverside, Cornell University, the University of Arizona, blah, blah, blah. So you see, these are the people who are active in this type of research. If you are in Denmark, that would be like this university here, American University in Beirut, if you are in Lebanon, and so on. Okay. Okay, let's move to now here search. Now this is something new, like augment your search with generative AI. So you can once like here, like you can like the way to do it here, like is that you will go through this one. Yeah, like you go through this search, like you ended up with whatever 351, and you just like it's easy. You just go through the title, and if you need to know the abstract, and then you get the ones that are relevant to you and save them, and you can use them later. So, and here in that case, we have like about 8 pages. I think like for me to go through this 8 pages will take me about half an hour to just like because you just like by reading the title I would know whether this is relevant or not. If I'm unsure whether this is relevant or not, I will just start like looking at the abstract. If I find it relevant, what I generally do, I will just do it. I will put it here, and then I will find the full text. So after I put it here, I will click here, and now I have the full text for this advances in water resources. Now I got the full text, and then I will down save it to my computer. Yeah. That's basically how I find papers. Let's do another one here. Let's say this is relevant to me. I will open it here. Yeah. And then once you open it here, it tells you like full text from the publisher. And then you click here and then you just like save it to your computer. Yeah. So you save it. Yeah, that's like how you do this. Okay. Let's go back here to our slides. Now, if you can, that's basically like yeah, how to get like to collect this article. Now, if you this is something like you can augment your search with generative AI. So generative AI, there are like many of them whichever one you want to use, like ChatGPT, Gemini, Consensus, whatever. And the idea here, like if you want to get like good results, you need to provide good details. So, and this you don't use it for. That's very important. Like you don't use this for your main literature search. Like your main literature search, you should come from here because that's where you will be able to know, get a comprehensive understanding of what's going on. Yeah. So you start by here, then after this you go to Google Scholar. So let's say like Google Scholar, like Google, like after you do Web of Science, you do Google Scholar just to make sure that you didn't miss anything. Let's say, for example, ground. That's one of my research area. So I'm searching for article about groundwater sustainability. Then you see here, this is like that would be the main articles that you don't want to miss. So basically, like you can go for the first like 5 pages. So like you see here, that is probably one of the most important article about this topic, which is published in Nature. This is one of the top journal. That's like another important article. Here is the third one. Oh, so thanks Google put my article here. Thanks Google. And uh, and then like you just want to go maybe for the first 4 or 5 want to make sure like so that would be make sure that you didn't miss anything. But like you see, you don't have much options here. You can only filter by date, like very few, not as extensive as the options that you have here. Okay. But with generative AI, sometimes you are looking for something very specific, and you can augment your search by just like targeting very specific topic or something that you cannot really like you did your keyword, you find your main article, but you want something very, very specific. So I found like generative AI could be useful. And generative AI basically, in order to make it useful, you need to provide context, task, constraint, output structure and without redundancy. So you need to, like, that's how you get, the more detailed and structured your prompt is, the better results you will get. And here I just put some generative AI tools. These are general one, ChatGPT and Gemini by Google. These are ones that you can use to search for research article like consensus, uh, and you can just learn these on your own. Like I will just show you like this example. I didn't do this before this class, but let's just do it together, yeah, and see what we will get. So I will just do this with ChatGPT here. So let's read this together and let's see what we want to do. So with ChatGPT, like you just copy and paste it. So what I want to do here, I want to find, like, let's say I'm writing an article, a paper about like generative AI and the future of higher education. Yeah. So now I'm drafting. So and I want to, like, let's say I'm writing. That's the general article, and then the specific paragraph that I'm writing at the moment would be something about like the human expertise in the AI era. So like because AI can would replace a lot of the jobs that we are doing because it can automate and do a lot of what we are doing. But what are the core human expertise that AI will not be able to replace or do or automate? Yeah, that will you still need human expertise. What are these like core or like main human expertise that AI cannot do? And again, this is about the future, not current. Like currently, maybe AI cannot do anything, but in the future, it could do much of what we are doing. Yeah, because you have this something called like agents, which is and the scientific agents and automated scientific agents. So that could like these are things that are still being developed, and once they are developed, they can do much. Yeah. So now we want to know what are these durable human skills that AI cannot replicate. So that's basically I want him to find like articles about this ones. And that's like if we search this one's Web of Science, we might not get exactly what we want. So here that could be helpful when you do this. So here, how do you write this? Like so you need to provide context first. I'm writing a peer-reviewed manuscript for a Q1 journal, like good journals, on generative AI and the future of higher education. I'm drafting a section on the re-evaluation of human expertise in the AI era. So here I'm giving him the context of what I'm doing. Here I'm giving him like again more context. So that's the general context, that's the specific context. And then please find or summarize. I mean, I don't want, I'm just putting this for you, but I don't want him to summarize. I just want him to find three peer-reviewed article from reputable journals. So you see here, I'm defining a task. I'm very specific. Like I'm putting some constraint from reputable journals that discuss the redefinition of uniquely human expertise and durable human competency that remain essential despite advances in AI. For each article, provide a full citation in AP format. See, I'm providing him detail. And then a short summary of key insights and explain how it contribute to the theme of re-evaluating human expertise in AI era. So let's do it like let's do it first without this one. I generally don't like just like here I just want him to find, not to summarize or anything, and then let's do it. So let's do see if how good it will be able to do it. I didn't use ChatGPT 5 before, and I'm trying this live with you, but let's see how. I didn't. I use ChatGPT 5, but I didn't use it to search for this. Like I did this before with the previous version of ChatGPT, ChatGPT 4, and usually it was very good in finding like very good article. But let's see here if it will be doing this. So so you see now it's searching. Uh, 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 let's see if it will can find something. Yeah. Uh, yeah. It's taking so long to search, but that's okay. Evaluating. So now it found something. It's evaluating them. verifying, see is if it's like a reputable journal or not, changing article detail, verifying journal detail, gathering citation information. So you see now it's gathering the citation information. Okay. Finalizing citation details, uh, searching for, oh, now it's searching for a third article because I told him find three, searching and proceeding of the National Academy of Science. Uh, that's a very good journal, Proceeding of the National Academy of Science. That's one of the most reputable journal. Finalizing article selection. So you see, it's finalizing article selection. I think that's a good, yeah. Finalizing APA formatting. APA formatting, that's just like to put the American Psychology Association formatting, where you put like author name, title, journal name, and things like that. So here is, so you see, wow, it find like one paper in Nature. That's a very reputable journal. Oh, another paper in Nature. That's another reputable journal. Uh, oh, but this is scientific report. Like this is Nature Human Behavior. That's a reputable journal. Scientific reports, that's okay. And then it find another one in Pen S. So what you do, like, see, I didn't tell him to summarize it, so that's exactly just what I want. So he find it for me, and then you open the link, and then you human competency and AI, and then you download the article, and then you just like you download the article, and then you find what you're looking for. Yeah. It's very, it's very neat. You just found what you're looking for, then you read the article and you cite it. Yeah. Okay. So that's basically, but you can, yeah, like, so that's basically if you want to use these tools. Source credibility, we talked about source credibility, like you peer review status, like the publication venue and the author qualification. So that's like how to check the credibility. Sorting, we looked at sorting, like we can sort by relevance, we can sort by recent article versus like highly cited article impact. We can sort by the impact factor, like the articles that are cited more. Uh, and the citation class, we can this is, yeah, I mean, you can look at this detail, like the citation class. I think this is a new feature that the Web of Science is providing. This citation class here, basically what you can do, I mean, you can try it. I mean, I don't want to make this video too long, but you can try it. Uh, it will tell you where is where I was able to find like whether this is in the back, like this paper, you can use it in the background information or in like the method or whatever. Yeah. So how to identify key article? Again, this could be matrix based, like you can select the articles that are highly cited or article in good journal, or experience based, or whichever like that are relevant to you. Okay. This is a systematic review. So the systematic review. So for example, like you see in this example, like we our original search was able to find like 130 records. So this 130 records, in our case with the new search, we got like 350 record. 120 record were excluded at the abstract stage. So abstract stage means I look at the title. If it if it's relevant, I look at the abstract. If it is relevant, I keep it. If it's not relevant, I exclude it. So by excluding at the abstract stage, I excluded out of 138 articles, I excluded 122 articles. So I excluded most of them. Most of them were irrelevant. Then I ended up with 16 records. So this 16 records, what I will do, I will get the full text, just as I showed you here, like you get the full text. So I will get the full text, and then I will read the full text. After I read the full text, guess what? 6 articles were excluded after full text assessment. So after I read the full text, and reading the full text does not mean that you read it word by word, but you just like read the abstract, You look at the introduction, see if it is relevant or not, look at the results, look at the figure, and then you will get a feeling whether this is relevant or not. Yeah. After the full text, 6 article was removing, and I ended up with 10 articles. So I started with 138 article. I ended up with only 10 articles that was relevant, that I needed for my research. Out of 138, 10 was only 6 paper was about groundwater remediation, 3 paper was about groundwater management. And these are the articles that I needed and that I cited. Okay, so here, this is your homework. Yeah, I hope this video is getting long. I don't like to make long videos, but anyway, this is your homework. So for not homework, like your participation activity. So basically, like use a web of science and find like 10 key scholar resources related to your research, and then document this, and then use generative AI, any one of them, any one. Like if I just showed you this with ChatGPT, but you can use consensus is usually very good also for finding a peer review article, like a peer reviewed article. But ChatGPT is equally good. Like you can try consensus, it will give you a different experience. But I mean, you can play with these ones and see whichever one you like. So part two is so here for this one, just like find like 10 key scholar resources related to your search, and then use generative AI to find 2 additional sources, so that would be 12, and then read at least 2 of classmate posts and suggest way to improve their search. Why do I give you this task, like review and suggest for your classmate? Because there are different reasons why I give you this task. Because you learn better when you learn with someone. When you work together and learn together, that's basically like educationally speaking, you learn better. So that's one reason. But also, this makes the class fun, because don't think of this as like kind of homework or assignments that you have to do, but this is fun. This is like going to like social media for Facebook or whatever and posting something there. So basically you post something there, and then like your friends, which is like your classmate in this case, will like read your post and comment on your post. So see it in this way, see it as a fun activity. Like I'm posting something on social media, and then I get some experts, yeah, now, who are like reviewing my posts and providing me with feedback and interacting. So make it fun and interact with each other as much as you can. Like what I'm giving here is just the minimum interactions that I'm expecting to get the grade, but the more you interact with one another, the better and more rewarding that learning experience will be. Okay, so that's it for this video, and sorry for this long video, uh, but yeah. Okay, so see you in the next video.